Hello. In this brief presentation, I am going to introduce you to the Educational Technology Group in CDAC Mumbai. Education at all levels faces a number of challenges. They come in the way of ensuring quality education being imparted to the learners. One major issue is lack of teachers, both in quality and quantity. We also lack adequate infrastructure from schools to classrooms and furnitures. Learners in remote areas pose another challenge. In the current industrial production mode of schooling, where any individual learner is a small component in the class, individual attention and feedback is rarely possible. Instruction, usually in the form of lectures, is delivered to the group irrespective of individual backgrounds or profile differences. Even when evaluating assessments, very little individual feedback is generated. While there are exceptions, by and large, this is the state we are in. Exploiting technology to address such problems has always interested the educational community. Any and all kinds of technology, from computers to smartphones, specialized gadgets, process automation, etc., have all attracted attention in this regard. Use of online testing, lecture slides, lecture learning management systems, and so on are quite popular today. Effective exploitation of technology options to gain the maximum benefit without having to invest enormous amount of time is the main challenge here. There are educational technology groups and champions all over the world precisely for this reason. The Group on Educational Technology Group at CDAC Mumbai was set up around the year 2000. Recognizing the then slowly emerging field of e-learning. There was much hype around that term in those days, and we attempted to look at the field from the base and see what is useful and what is not. We started with the Vidyagas project, a national resource center for online learning, the first major project in e-learning in India. We explored many aspects including synchronous video lectures, asynchronous learning, assessment, feedback, and so on. With IIT Bombay, we conducted the first synchronous one-semester course over satellite covering multiple centers. Tools like Vasista, Chhatra, Veda, and Vyasa were built during this time. Unfortunately, most of these were ahead of their times. Veda was a question banking and online testing system, something very common these days. CDAC Mumbai, formerly NCST, had a version of Veda in the late 80s. Vyasa was a question generation system, a topic which is beginning to attract attention now. Technology in education is today a large area with many aspects. Every technology is being explored on every aspect of education. Broadly, we can divide the aspects into content, assessment, monitoring and feedback, collaboration and communication, and miscellaneous. Miscellaneous will cover learning management systems, attendance systems, tools for handling administrative tasks, and so on. Most of the focus in our team was in content, monitoring, and assessment. Over the last 1.5 decades, we have contributed much in these areas. A lot of our efforts over the last few years have been specifically in the context of school education. There is one thing we have realized through all these experience and exposure. Except in specific cases like corporate training, the role of the teacher in exploiting technology effectively is critical. There are no universal winners or losers in the technology space. A teacher, when motivated, can evaluate a technology from the perspective of the teaching learning process and fit it in the right place in this process. Even a lecture slide does more harm than good if not used properly. What to put in the slide and how is not prescribed by technology. Therefore, we see most of the technologies as teacher amplifiers, amplifying the effort and capability of a good teacher. Content today spans a wide range from the age-old plain textual description with some pictures perhaps, to high quality interactive simulation systems. Cost of development increases in this spectrum, but the effectiveness of the content also increases in the same direction. Most of our focus in this area has been on tools and frameworks for content creation and personalization. The team has explored many open source tools and feel confident to recommend open source for most of the requirements in this area. Good solutions are available for common requirements like audio recording, screen capture, audio editing, video editing, image editing, textual writing, content organization, and so on. For example, Audacity is a great piece of software for audio recording and editing. Here are a few of the tools we have been playing with and that we are fond of. Mind maps are an alternate way of representing a domain structure and can be used to capture your understanding and even assess the same. FreeMind and VUE are good mind mapping tools available free. The picture you are seeing on the screen is a map created using VUE. Open education resource movement across the world is an important dimension today and should be explored when looking for content and resources in any domain. Intelligent tutors is a very advanced type of content usually aimed at very small aspects involving problem solving. And the physics tutor from CMU is an example. Our team had worked on a Marathi language tutor, English grammar tutor, solving simultaneous linear equations, etc. following this track. For assisting learners in domains like biology and maths, we have created what we call T-Labs. These are tools that a teacher can use in the classroom. One common activity for a maths teacher is to show derivation or proof of some hypothesis. One does this through a sequence of steps. A T-Lab component records these steps on a timeline, allowing the teacher to fold back the steps for answering questions or clarifying something. One can also repeat the steps many times, having done it once. Another T-Labs component provides for a variety of activities around a diagram which plays a key role in biology classes. An interesting type of content which requires significant software development is virtual labs. Our OLabs project has produced over 150 school lab activities in subjects such as physics, chemistry, biology, maths, and English. These are accessible free online at www.olabs.edu.in. You can find more information on this elsewhere. Another important practical skill of interest is programming. Computer education in India has been widely criticized for the poor practical knowledge that students acquire during the degrees. Parikshak is a web-based program grading system which can be used as the base for programming labs and also for evaluating programming skills effectively. Assessment is one aspect where technology can play a very major role, but unfortunately not much attention is usually given here. The increased adoption of multiple choice based examination is one positive example. As I mentioned, we had built a system for conducting this kind of examinations almost 3 decades back. Today, many systems are available for this. Most learning management systems have built-in provisions for question banking and for conduct of MCQ-based examinations. There are many challenges here though. Security is a major concern. Ensuring minimum loss of data in case of machine crashes, power failures, etc. is another. Though MCQs are easy to evaluate, it's also most amenable for copying. Systems need to incorporate option scrambling, question scrambling, and dynamic question selection to address this. A new version of Veda has been developed by the ETU team addressing all these concerns well. Many believe quite correctly that MCQ-based testing is not complete and insist on some subjective questions. Many universities still have their final exams as a set of subjective descriptive answer questions. The challenge here is the many hurdles in evaluation of these answers. These include ensuring consistent marking across students and questions, and the time needed to read and understand the answers, not forgetting the handwriting analysis required at times. Some research studies are in progress to develop support systems to help in evaluation. Meanwhile, providing a system for conduct of such examinations and supporting the teacher in systematically evaluating the answers can be helpful. DES is an attempt in this regard, and it allows the teacher to navigate the set of answers in student by student mode or question by question mode, improving the consistency. It also flags unanswered questions to the student and unevaluated answers to the teacher. We also have a system which can help in OMR type of multiple choice question examinations without having to use specialized OMR scanners or specially printed OMR sheets. This OBRIC system has been used successfully for internal examinations and competitive examinations for some external agencies. Another challenge in a learning environment is monitoring and feedback. Our AMF system, currently aimed at schools, provides a framework to collect detailed exam scores and use this to provide high quality analytics reports. Apart from individual performance reports, one can get student in a class analysis, subject-wise analysis, trends across years, sudden variations in performance, teacher performance analysis across subjects and years, and so on. Again, you can find more information on this elsewhere. I conclude this brief walkthrough of our work with two other existing interesting systems. eBasta is an attempt to ease the adoption of ebooks for regular use in schools. A portal, ebasta.in, brings all publishers, including state boards, NCERT, private publishers, and even teachers who want to share resources on one platform, enabling teachers and students to browse the available resources for their classes and subjects of interest easily. Teachers can bundle their selected compilation of resources into eBastas and make them available to students. An app is available free for navigating this bundle. This framework frees the student from having to search around for quality resources and downloading them individually and having to figure out how to find them on their tablet or computer. This can help a long way in addressing the popular concern of heavy school bags. More information is available in a companion presentation on YouTube. One dream that many share with the use of technology like computers in education is a chance to realize personalized instruction. Anurup is our attempt to build a framework for personalized instruction delivery. A content markup language called PCML has been designed to mark up content in a fairly deep manner for personalization to work effectively. This tags content at a fine granularity based on pedagogical role of a sentence or small paragraph. Learner profile, including prior knowledge, media preference, language preference, dominant learning style, etc., are used to transform the base content in a way that is suitable for the learner. The transformation includes filtering and reordering based on learner profile. For example, for some, example, definition, explanation is a good order to introduce a concept, whereas some others may prefer definition, explanation, and then examples. This idea of personalization has also been used by us to build a learning environment for children with learning disabilities as part of a PhD thesis work. In all these areas, we play many roles. As technology people, we try to internalize the available technology solutions for a proper assessment and use this to offer training on such solutions to those interested. Our workshops on Moodle, a popular LMS, is an example. We are strong believers in open source movement and also with open education resources. We use almost exclusively open source softwares for building our solutions. And the solutions built are also usually shared freely with the target users. Where we build extensions to existing softwares, we usually give back the extensions to the community for furthering the growth of the software and the movement. Most importantly, our role has been to identify gap areas and build solutions in those areas. We have avoided duplicating solutions already existing, particularly if they are open source. I hope this brief exposition has given you a feel for the work we do and our motivations and driving forces. Do feel free to get in touch with me if you want to be part of what we do and contribute to bettering education around. Thank you.